So hello everyone. Um, in this video, we are going to look at another approach to solve the maximum sum of subarray problem, and this approach is called as prefix sum approach. So before directly diving into the code, let's just go through our usual dry run. Okay, तो बेसिकली अभी तक हमने दो अप्रोचेस पढ़ ली है to solve this problem. Okay, so first one was brute force. That is nothing but our regular approach, regular regular approach. Okay, and in this हम क्या करते थे, we were having three for loops, I, j and k. I to depict the start, j to depict the end, and then k to go from start to end. Okay, and the time complexity in this case was O of n cube, and space complexity was O of 1. um, and then approach 2 was the cadence algorithm, which was basically the best approach. Okay, why it was best? Because we were using a single for loop, and time complexity was O of n, and space complexity was O of 1. Now the third approach, which we haven't discussed yet, is called as prefix sum approach. So the time complexity in this case would be O of n square. How? We will discuss the approach in detail, and space complexity will be O of n. Okay. So first thing, अगर हमें ऑलरेडी रेगुलर अप्रोच पता है, हमें ऑलरेडी बेस्ट अप्रोच पता है, then what's the point? Basically, why we are discussing this prefix sum approach? The reason why we are discussing this prefix sum approach is we cannot skip it. Okay, even if we skip it, there's no harm because we already know the best approach, but we should not skip it ethically. Reason, because it plays a very important role in contributing towards the logic building. Okay, so हमेशा ये चीज important नहीं है कि हमें सिर्फ बेस्ट बेस्ट वाले algorithms या बेस्ट अप्रोचेस पता रहे एंड हम सिर्फ बेस्ट वाले याद रखें, एंड फिर जो कम अच्छे हैं या फिर जो बेस्ट नहीं है उन वो हम अटेम्प्ट भी ना करें या उनको समझे भी ना. No, it is very important to understand this approach as well. Why? Because it contributes to logic building. Okay, now second point, which I want to highlight here is that officially, ethically, okay, you go through any online DSA course, and any lecture series or videos or any YouTube playlist. Officially, what everyone does is they first tell you this approach, then they tell you this approach. Okay, and then at the last they tell you the best approach. Okay, so पहले वो आपको सबसे खराब जो है O of n क्यूब वो अप्रोच बताएंगे, देन वो आपको स्लाइटली बेटर जो है prefix sum approach, that they will tell you O of n square and space complexity O of n, and then at the last they tell you the best approach, which is the regular process. Okay, and ऐसा होना भी चाहिए, but I deliberately first told the regular approach, which is brute force, then I deliberately told you the cadence algorithm, which is best approach, and then at the end I am going explaining this approach. Reason why I am doing this is because both these approach 1 and approach 2 are easy to understand. ओके, ये बहुत इजी है समझने के लिए, ज़्यादा मेहनत नहीं लगती. हाउएवर दिस अप्रोच इज लिटिल बिट ट्रिकी. ओके, लिटिल बिट ट्रिकी, थोड़ा सा डिफिकल्ट है. सो दैट्स व्हाई आई प्रिफर to understand or try this algorithm at the end, because you already know now these two approach, which are easy to understand. Now let's jump into this one, which is slightly tricky. Okay, when I say it is slightly tricky, it is, but believe me, it is also very simple. Okay, so if you know the intuition, if you know the logic behind it, it's easy to code. Okay, so simple. When I say space complexity O of n है, okay, when I say space complexity O of n है, okay, so naturally we are going to use extra space, correct? So naturally we are going to use extra space, and when I say time complexity is O of n square, so naturally we are going to use one nested loop. ओके, सो आई एंड जे दोनों लगेंगे हमको, करेक्ट। तो यहाँ तक समझ गया। सो फर्स्ट थिंग इज वी आर गोइंग टू रिक्वायर, वी विल रिक्वायर extra space or an extra array, and second we will require nested for loop that is I and j। ओके, ये दो चीजें श्योर हो गई, राइट। ओके, नाउ प्रीफिक्स सम अप्रोच बोलता क्या है। ओके, व्हाट डज प्रीफिक्स सम अप्रोच स्टेट्स। सो सिंपल, सिंपल है बॉस। व्हाट इट सेज इज, ये एरे हमको गिवन रहेगा। ओके, ये एरे हमको गिवन रहेगा 2 -1 3 7 0 -3 4 -1 और एनी सच रैंडम एरे, इट विल बी गिवन टू अस। ओके, ये हमको गिवन रहेगा। व्हाट इट सेज इज, हम एक खुद से एक अलग एरे बना लेंगे। लेट्स जस्ट नेम इट प्रीफिक्स। ये एक एरे है एंड इस एरे में हम क्या करेंगे, इस एरे में हम कंसेक्यूटिव एलिमेंट्स का सम स्टोर करते जाएंगे। ओके, सो फर्स्ट थिंग इज, अगर इस एरे की लेंथ 1 2 3 4 5 6 7 8 है, ओके, तो प्रीफिक्स एरे भी 8 लेंथ का ही बनेगा। ओके, तो अगर इस एरे की लेंथ 8 है तो प्रीफिक्स सम भी 8 लेंथ का ही बनेगा, नंबर वन। ओके, नंबर टू, what we will do is we will keep on adding the sum of consecutive elements in this array। so first position तक elements का sum क्या है, 2। so first position पे 2 जाएगा। second position पे -1 है, तो first two elements का sum क्या है, 2 - 1 is 1, इसमें 1 जाएगा। then थर्ड क्या है, 3। so first three elements का sum क्या है, 2 - 1 1 + 3 4, correct। then 2 - 1 1 + 3 4 + 7 11 11, okay। then 11 + 0 again 11, then 11 - 3 8, okay। then 8 + 4, ठीक है, 12, and then what, 12 - 1 11, ओके, परफेक्ट। ये एरे बन गया। ओके, सो इन अवर algorithm, ठीक है, व्हाट विल बी अवर इनिशियल स्टेप, स्टेप 1, ठीक है। स्टेप 1, डिक्लेयर करंट सम एंड मैक्स सम वेरिएबल्स, ठीक है। करंट सम विल बी इनिशियलाइज्ड टू 0 and maximum sum will be initialized to integer dot min underscore value as we usually do, ठीक है। ओके, स्टेप 2, declare and initialize, declare and initialize prefix, declare and initialize prefix array। ओके, declare and initialize prefix array, perfect। ओके, तो अब ये करना कैसे, तो ये हम करेंगे कैसे। ओके, प्रीफिक्स एरे डिफाइन कैसे करेंगे, ठीक है। डिफाइन तो कर देंगे बट हाउ वी विल इनिशियलाइज इट, ओके, दैट इज द क्वेश्चन। सो व्हाट वी विल डू इज, हम पहले प्रीफिक्स ऑफ 0, जो फर्स्ट एलिमेंट है हमारा, ठीक है, प्रीफिक्स ऑफ 0 जो है फर्स्ट एलिमेंट, हमारे प्रीफिक्स एरे का फर्स्ट एलिमेंट, ओके, उसको हम एरे के फर्स्ट एलिमेंट के बराबर कर देंगे। फर्स्ट ऑफ ऑल व्हाट वी विल डू इज वी विल इनिशियलाइज फर्स्ट एलिमेंट ऑफ प्रीफिक्स एरे with the equal to that of first element of our given array, okay। so prefix of 0 is equal to arr of 0, first thing। then we will do a for loop for I is equal to 1. Okay, I is equal to 1, I less than prefix dot length and then I plus plus. Okay, and ये हो गया. So what we'll do is now we will start from index 1 in prefix array. 0 हमने पहले बराबर में इनिशियलाइज कर दिया. And then what we will do is we will start from index 1. That's why I is equal to 1 लिया है. Okay, and what we'll do is prefix of I. Okay, prefix of I is equal to prefix of I minus 1 plus ARR of I. Okay, तो ये चीज़ बहुत इंपॉर्टेंट है, याद रखना सब लोग. ठीक है, ऐसे और इम्पोर्टेंट चीज़ें आएगी. ओके, ऑल इम्पोर्टेंट रिलेशंस will pop up in upcoming part of this very same video. So remember this logic. So what we did is prefix of I, that is prefix of 1. Okay, prefix of 1, that is first position, is equal to prefix of I minus 1. What is I minus 1? 0. So what we are doing is prefix of I, that is prefix of 1, is equal to prefix of 0 plus ARR of I. Now what is I? I is 1. ARR of 1. What is ARR of 1 is minus 1. So automatically what we are doing is 2 minus 2 plus minus 1, that is 1. So prefix of 1 would be 1. Correct. एक iteration हुआ, then I plus plus. Now I will become 2. Okay, so prefix of 2 is equal to prefix of I minus 1. What is I minus 1? 1. So prefix of 2 is equal to prefix of 1 plus ARR of I, that is ARR of 2. Now what is 2? 3. So 1 plus 3, 4. Correct. 1 plus 3, 4. Correct. So we will keep on doing this. ऐसे सारे iterations run होते जाएंगे and we will get our prefix array. Okay, so this was step 2. In step 1 we declared our variables. In step 2 we declare and initialize prefix array. Now how we do that? Prefix of 0 is equal to ARR of 0, we do it initially. Then for I is equal to 1, I less than prefix dot length I plus plus, we do it. And then prefix of I is equal to prefix of I minus 1 plus ARR of I. Okay, I think it's very clear. It's very clear. यहाँ तक clear है. ठीक है. Step 3. Step 3, nested for loop. ठीक है. Now how? Now how? Okay. So we will start our regularly I for I is equal to 0. Okay, I less than ARR of ARR dot length and then I plus plus, and then similarly what we will do is for j is equal to 0, j less than, oh sorry, j is equal to I. Okay, so remember in the previous videos, okay, I told you we start j is equal to I. Okay, and then if you remember that regular approach video, in this we always used to start from j is equal to I. Okay, j less than ARR dot length and j plus plus. Correct. Good. And now um, inside this again, what we will do is, now remember this is very very important. This is the most important line of this code. Okay, current sum is equal to prefix of j minus prefix of I minus 1. Okay, now how this is current sum? How this is current sum? Let me tell you. Okay, how this is current sum? ये line कहाँ से आई? Okay, no need to basically रट्टा और रट्टोफाई this line. Okay, we can understand ये line आई कहाँ से. Okay, it's simple. It's simple. एकदम ध्यान से फोकस के साथ सुनना। ओके, व्हाट इज आई एंड व्हाट इज जे इन दिस। ठीक है, अगर तुमको मेरी पुरानी वीडियो याद है, इन विच वी डिस्कस दिस रेगुलर ब्रूट फोर्स अप्रोच, ओके, ब्रूट फोर्स अप्रोच, इफ यू रिमेंबर दिस वीडियो, ओके, वी वर हैविंग थ्री लूप्स, करेक्ट, आई जे एंड के। ओके, अब इसमें क्या है, सिर्फ आई जे है एंड थर्ड जो हमारा के वाला लूप है, ओके, वो गायब हो गया है। वो के वाले लूप की जगह बेसिकली ये स्टेटमेंट आई है। ठीक है, वो के वाले लूप की जगह ये स्टेटमेंट आई है, करेक्ट। सो इफ दिस स्टेटमेंट इज रिप्लेसिंग के लूप, ओके, दिस इज रिप्लेसिंग के लूप, ओके, करेक्ट। तो इसका मतलब ये स्टेटमेंट, दिस स्टेटमेंट इज वर्किंग सिमिलर टू व्हाट दैट के लूप का जो काम था, उसके सिमिलर अब इस स्टेटमेंट का काम है। ओके, सो वी हैव एलिमिनेटेड दैट के लूप, ओके, एंड के लूप जो काम करता था, द सेम वर्क इज डन बाय दिस वेरी सेम स्टेटमेंट, करेक्ट, करेक्ट। ओके, बट के लूप करता क्या था, ओके, तो आई लूप से बेसिकली हमको एक स्टार्ट मिलता था, ठीक है, स्टार्टिंग पोजीशन। जे लूप से हमको एक एंडिंग पोजीशन मिलती थी, एंड देन के लूप क्या करता था, उस स्टार्ट से लेके उस एंड तक, फ्रॉम आई टू जे। ओके, सो हाउ वी यूज टू राइट दैट के लूप, इफ यू रिमेंबर, फॉर आई एन टी के इज इक्वल टू आई, के लेस देन इक्वल टू जे, के प्लस प्लस करंट सम इज इक्वल टू करंट सम प्लस ए आर आर ऑफ के, करेक्ट। तो के को हम आई से जे तक लेके जाते थे, करेक्ट। सो नाउ वी हैव एलिमिनेटेड दैट के लूप। इंस्टेड ऑफ दैट व्हाट वी आर सेइंग इज, इफ यू वांट टू फाइंड सम फ्रॉम आई टू जे, ओके, के लूप का काम क्या था, आई से लेके जे तक का सम निकालना, करेक्ट। इंस्टेड ऑफ दैट what this approach states is, you use this prefix array, you use this prefix array and you find the sum from I to j using this formula. So consider value of I is 1 and value of j is this 0 1 2 3 4 5, and value of j is 5. So I is equal to 1 से लेके j is equal to -3 तक, यहाँ तक हमको इस सब एरे का सम निकालना है। ओके, सो लेट्स जस्ट स्टेट इट, आई इज इक्वल टू 1, सॉरी 1 2, जे इज इक्वल टू 5, यहाँ तक का हमें सम चाहिए। ठीक है, तो व्हाट इज अवर की फॉर्मूला इन दिस, की फॉर्मूला, की फॉर्मूला इज करंट सम इज इक्वल टू, सॉरी, करंट सम इज इक्वल टू prefix of j minus prefix of I minus 1. Okay, prefix of j minus prefix of I minus 1. Let's just apply this. J की value what, 5. What is prefix of 5? 0 1 2 3 4 5 8, correct, 8। तो हम लिखेंगे यहाँ पे is equal to 8 minus I minus 1. What is I की value, 1, so I minus 1 is 0. What is prefix of 0? 2, okay, 2 6। ठीक है, अभी I से लेके J तक का सब एरे का सम देख, लेट्स सी व्हाट इट इज। -1 + 3, 3 - 1 2, 2 + 7 9, 9 + 0 9, 9 - 3 6, मिल रहा है एग्जैक्टली 6। ठीक है, सो इन दिस ब्रूट फोर्स अप्रोच, के लूप का जो काम था, टू कैलकुलेट सम फ्रॉम आई से लेके जे तक का, के इज इक्वल टू आई एंड के लेस देन इक्वल टू जे, के प्लस प्लस जो हम करते थे, दैट लूप हैज बीन एलिमिनेटेड, एंड इंस्टेड ऑफ दैट व्हाट वी हैव डन इज प्रीफिक्स एक एरे डिफाइन कर दिया। ठीक है, एंड प्रीफिक्स एरे कैसे डिफाइन किया, वी हैव ऑलरेडी डिस्कस्ड इन स्टेप 2। ओके, एंड देन एट द एंड व्हाट वी डिड, नेस्टेड लूप, नेस्टेड लूप के अंदर what we did is current sum is equal to prefix of j minus prefix of I minus 1. ठीक है, अगर आप नेचुरली इस लॉजिक को याद रखते हो तो देर इज नो नीड टू रिमेंबर दिस फॉर्मूला. ओके, it's simple, prefix of j minus prefix of I minus 1. Okay, prefix of j minus prefix of I minus 1, and simple. At the end, again, what we do as usual, if current sum is greater than max sum, ठीक है, then what we do is max sum is equal to current sum. Nothing new in this, we have already discussed this, and at the end, return max sum. Okay, return max sum. Okay, very simple, very simple. Okay, so let's just now go through the complete dry run once again, and then we will code it. Okay, so let's just go through the dry run once again. Okay, we have been given an array. Okay, what we will do is we will first initial our regular variables current sum, maximum sum. Current sum will be initialized to 0, maximum sum will be initialized to integer minimum value. Okay, declare and initialize prefix array. So how we do that, we first declare prefix of 0 with ARR of 0. So whatever is the first element in our array, we declare it same as prefix of 0. So then we use a single for loop. Okay, we use a single for loop for I from I is equal to 1. Okay, remember this, from I is equal to 1, and then what we do is prefix of I is equal to prefix of I minus 1 plus ARR of I. Okay, and then by doing so we get what, this array, we get prefix array. So in step 2 we declare and get done with declaring and initializing prefix array. Okay, and then what, nested loops, I starting from I is equal to 0 and j is equal to I. Okay, what is role of I here? To give a start. What is role of j here? To give a ending point, to give a starting point and give a ending point. And what we used to do in our regular approach, brute force, we used to have a third for loop for k, right? K loop. Okay, and then what we used to do, k is equal to I to k is equal to j. Correct, k is equal to I to k is equal to j. Instead of that, we are now using this prefix array which we have declared in our step 2. Okay, and what we are doing is current sum is equal to prefix of j minus prefix of I minus 1. Correct, and then if current sum is greater than maximum sum, we are updating maximum sum accordingly. At the end we are returning maximum sum. Okay, I hope dry run is crystal clear. It's very easy. थोड़ा सा tricky था as I told you, but it's very easy. Okay, so let's just now code it. Okay, mm, until n is equal to s dot extend. Okay, and int arr is equal to, okay, let's just randomly declare our array as we have done here. Hmm. Let's just take this array. Hmm. Okay, and comma, 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 comma. Okay, okay. One warning now. Okay, no, actually, not warning exactly. What I mean to say is, now before I am starting the actual code, what you guys do is you pause the screen. I have explained you the logic. I have explained you the dry run. Okay, I have told you the formulas. Now what you do is you open your IDE, pause the screen. Okay, and then you try on your own and see if you are getting the same result. Okay, and if you are not able to code, then no, now you resume the video. Okay, so I hope you guys have really paused the screen and by on your own you have written the code or tried it yourself first. Okay, so this is our array, and what we'll do is we'll just print maximum sum, system.out.maximum println and maximum sum sub array, and we will pass our array as a input parameter to this. Okay, now let's just we have called our function. Now as usual, let's just define it here first. So static because it is going to return a sum which can be an integer. Okay, so static int and then maximum sum sub array. Okay, and int arr is our input parameter. Perfect. Okay, now let's follow the algorithm, okay, as it is, which we have discussed here. Okay, stepwise. Step 1, declare arrays, declare variables. Step 2, initialize prefix array. Step 3, nested for loops. Okay, int current sum is equal to 0, int max sum is equal to integer dot min underscore value. And so step 1 done. Then a single for loop to declare int I is equal to 1. But so before it, what we need to do is we need to declare a prefix array. So int prefix is equal to new int of arr dot new int arr dot length. Okay, and int I is equal to 1. And okay, one more thing we forgot, prefix of 0 is equal to arr of 0. ठीक है, int I is equal to 1, I less than prefix dot length and I plus plus, correct? And then what we do is prefix of I is equal to prefix of I minus 1 plus arr of I. Okay, done. ठीक है. By the way, if you guys have really tried the code and paused the screen, and now if you are looking at the code, I bet you guys have got an error. Okay, I bet you guys have got an error. Okay, and that's why I purposely told you to pause the screen and try. Okay, so if still you have not done, there is still chance you can pause the screen and then again code it and then come back. You should definitely get some error. Okay, so we are done with prefix array. Then nested for loop and g I is equal to 0, I less than arr dot length I plus plus for int j is equal to I, j less than arr dot length g plus plus. Okay, and then what, current sum is equal to prefix of j minus prefix of I minus 1. Okay, and then if statement, if max, okay, sorry, current sum is greater than max sum, then max sum is equal to current sum. Okay, and at the end return max sum. Okay, let's just try to compile it first. Okay, and but after running, I think we will definitely get some errors. Okay, sorry, my bad. I think here it should be the square brackets. Okay, uh, Okay, return statement should be here, like here. Okay, okay. Let's just now try to run it. I think we should get some error. Okay, we have got some error. And I think it's not an error, but it's an exception. Okay. Now to solve this exception, let's just again go to dry run. Okay. Okay. Let's just go to this dry run. Okay. So this was our key formula here. Our key formula is current sum is equal to prefix of j minus prefix of I minus 1. Okay, prefix of j minus prefix of I minus 1. Correct? Now consider I is equal to 0. So j will also be 0. So in this case, I is here at 2 and j is also here at 2. Now in this case, the subarray will go from I to j, that is from 0 to 0. So sum will be what? 2. So in such cases, okay, when I is 0, that is the first element. Okay, so current sum is what? 2. Current sum is what? 2. So in case when I is 0, the current sum is what? First element only. Current sum is what? First element only. So, and what have we written in our formula? Current sum is equal to prefix of j. So prefix of j, that is what? 0. Prefix of 0, 2 minus prefix of I minus 1. So what is I? I is 0, 0 minus 1 is minus 1. Prefix of I minus 1. This is causing that exception. क्या कभी array का index negative हो सकता है? No, it always starts from 0. Okay. So basically hence there is some rectification required. Okay, and purposely मैंने जानबूझ के when I was discussing this dry run, I didn't tell you that rectification. I wanted you guys to code it actually. Then I wanted you to get this exception, and now we are going to solve it. Okay, so what we'll do, we will put an extra if statement here. Okay, what we'll do is if I is equal to 0, if I is equal to 0, then in that case, okay, current sum is equal to prefix of j only. We don't need to do this minus of minus prefix of I minus 1. Okay, just this prefix of j. Okay, else okay, else okay, else what we will do is, else inside this else हम ये statement, ये formula लिखेंगे. Okay, and then again our regular if statement. Okay, if current sum is greater than max sum, then replace max sum. Okay, so now this algorithm is complete. Okay, now this algorithm is complete. Previously it was incomplete. Okay, previously it was incomplete. So we will do the same here. If I is equal to 0, okay, current sum is equal to prefix of j. That's it. Okay, and then in else part, else we will write this statement. Okay, and at the end we are having our regular. Let's see now if we get the exception or not. Okay, so we are not getting the exception and we are getting the result as 12. So 12 is the maximum sum in the sub array. How 12? So I think this is the sub array for getting some 12, or I think this is the sub array, this whole. So 2 minus 1 is 1, 1 plus 3 4, 7 plus 4 11, minus 11 plus 0 0, 11 plus 0 11, 11 minus 3 8, 8 plus 4 12. Okay, so starting from 2 to 4, this whole gives sub array, gives maximum sum. Okay, so I hope this complete logic was clear. So let me just take you through the dry run one last time. Okay, one last time. We declare current sum and maximum sum variables. We declare and initialize the prefix array, we the key part here is we need to do prefix of 0 as ARR of 0, and then start the for loop from I is equal to 1, and then prefix of I is equal to prefix of I minus 1 plus ARR of I, and then nested loops I is equal to 0 to give a start, j is equal to I to give a end, and if I is equal to 0, then current sum would be prefix of j. But if in else case, if I is not 0, in other regular cases, current sum is equal to prefix of j minus prefix of I minus 1. And then if current sum is greater than maximum sum. Okay, so I hope dry run is clear. Please start making notes side by side. I think your notes are going to help you a lot. Okay, there should not be any need to rewatch the video if you are maintaining the notes. Okay, of course, if you are not recalling any concept, you can always rewatch the videos. But I think if you start making proper notes and you revise timely, then there is no need of rewatching these videos. The logics are crystal clear, and they always there is no need to rectify or to learn by heart. We just naturally remember all the logics. Okay, so thank you everyone, really thank you everyone for watching till end. I'm sorry this was a pretty long video, and thank you everyone. So this is the final code. If anyone wants, you can pause the screen and take a screenshot. So thank you everyone for watching till end. If you feel I have made any significant contribution in your logic building, then please do subscribe and like the video, and I will see you in the next one. Thank you.